Okay, today's video is going to look at solving rational equations. Keywords there, equations, means we have something with an equal sign in it. We are solving, not simplifying. Rational equations, the word rational comes from ratio, and that means we're talking about equations with fractions. We're going to look at a couple different techniques, but the overall theme is going to be the same. We want to get rid of or clear out those fractions. Okay, so when you have an equation with fractions in it in general, you want to think about clearing out those fractions. These first two examples are the most basic type that we will see. They just have a single fraction on the left and a single fraction on the right. When we have that situation, we can use a technique you guys have probably seen before. That is that we can cross multiply. So cross multiply, bottom to top, 15 times 2 equals bottom to top, 5 times x minus 1. The order doesn't really matter, bottom to top or top to bottom, as long as you represent both crossways in your equation. 15 times 2 is 30, and we'll distribute on the right. We get 5x minus 5. We add that 5 to both sides. We get 35 is 5x. Divide both sides by 5 and we come up with x equals 7. But we are not finished yet. Anytime we are solving rational equations, it is very important, more than other types of equations even, that we check our final answer. And most specifically, what we want to check is that that final answer does not make the denominator equal to 0 in our original equation. A 0 denominator, that's dividing by 0, that is undefined. We can't have that. So we want to always go back and look at our original equation. Does our answer turn this denominator into 0? Well, this denominator is 15. 15 is never equal to 0, so that's okay. Same thing over here, the denominator is a constant, 5 is never equal to 0. So in this case, after a quick check, we can see that this answer is okay. We could do a more formal check where we plug 7 in for x and we make sure we end up with the same value on each side of the equation, but the most important thing is to check for the denominator being 0. Okay, let's do another one. This example number 2, same thing. Single fraction on the left, single fraction on the right, so we can cross multiply. 3 times x minus 8 equals 7 times 5. Again, it doesn't matter which direction you go when you cross multiply. We will distribute here and get 3x minus 24, multiply, and that's equal to 35. Add 24 to both sides. We end up with 3x equals 59. Divide both sides by 3, and there's our answer. X is 59 thirds. Go ahead and leave that as a fraction. If we turn it into a decimal, it's a repeating number, and so it's not an exact answer. So we want to leave that in its decimal form. But we are not finished. We have to go back and check. Check our original denominators. Over here on the left, we had 7. 7 is never equal to 0, so that's okay. On the right, this time we do have a variable. So if we were to put our answer in place of x, would that give us an expression that was equal to 0? You can plug this into your calculator or you can actually do the arithmetic, but I happen to know that 59 thirds is not equal to 8. So 59 thirds minus 8 is not going to be equal to 0. So this one checks out, and that is our answer. Okay, let's do another technique here. So that cross multiplying only works when you have a single fraction on each side. This time we do not have a single fraction on each side. We actually could turn this into a cross multiplying problem, but I'm going to show you another technique because this is what we'll need to use in the more complicated problems that we get to. So identify your least common denominator. When you have more than one fraction on each side of your equation, start off by identifying the least common denominator. In this case, it's pretty basic. Our least common denominator will just be 5x. And what we want to do is go through that equation and change up each fraction we see so that it has that common denominator. Our first fraction is 1 over x. In order to make that match our common denominator, we multiply the top and the bottom by 5. Our second fraction already has 5x in the denominator, so that one's okay. And our last fraction also has 5x in the denominator, so that's okay. Once we have a common denominator across all our fractions, because this is an equation, what we can do next is multiply everything by that common denominator. And what happens is when I distribute that through to all the pieces of my equation, it's going to cancel with all those denominators. That 5x is going to cancel with this 5x, and I'm left with just 1 times 5, which is 5. The 5x cancels with this 5x. I'm left with just 1. Don't lose that minus sign. That stays in there. The 5x cancels with this 5x, and I'm left with x minus 1. This is a much easier equation to solve. You can see we have cleared out the fractions. So we'll distribute that negative sign through. Combine those two ones together. We'll subtract 2 from both sides. And finally, divide both sides by -1. So there's our answer, but don't forget to check it. So we go back, always check in your original equation. If I put -3 in place of x, do I get a 0? No, I just get -3. That one's okay. If I put -3 in place of x here, do I get a 0? I get -15, so that one's okay. And same thing here. If I put in -3, I get -15. That's okay. So that x equals -3. That is our final answer. Okay, let's do another one of this type. I'm picking a different color every time. What color do you guys like best? Let's see. This one's boring. We're going to do brown. Okay, so again, start off. It's not a single fraction on the left and on the right, so we're going to start off. Oh, my pen's acting up again. We're going to start off by finding the least common denominator. Here, let's see, we've got an x plus 2. We need to include that in our denominator as one of our factors. Oh, sorry about the pen. Let's see if I can clear that up and try again. We need to include an x, and we need to include a 5. That x in the last one, that's already covered by this x, so there's our LCD. If we want to write it maybe in a more traditional order, it could look like this. So I want to do some work to make every fraction in my equation have that denominator, have that on the bottom. So I start off with 3 over x plus 2. I've already got the x plus 2. What's missing is I need to multiply it by a 5 and by an x. If I do that to the bottom, I have to do that to the top also. My next fraction is 1 over x. What's missing here? Well, I've got the x, but I still need a 5, and I still need an x plus 2. So if I multiply the bottom times that, I also have to multiply the top. Oops, sorry, that should be a 5 there. 5 times x plus 2. And then I have my equal sign. Over here I have a 5x. Only thing missing here is an x plus 2. So I multiply the top and the bottom. Then again, because this is an equation, I can multiply everything by that common denominator, and those denominators will all cancel. And we end up with 3 times 5x is 15x. That looks like 15, but remember that was a 1 times 5 there. So just 5 times x plus 2. And 1 times x plus 2 is just x plus 2. Again, fractions eliminated, a much easier equation to solve. We will distribute that -5 through there. And then combine some like terms here. And finally, let's move our x over. And in the same step, we can move that 10 over. We get 9x equals 12. Divide both sides by 9. That can be simplified. X is 12 over 9, which simplified would be 4/3. Okay, don't forget to check. So we go back to our original equation. 4/3 plus 2. That's our first denominator. Is that equal to 0? It's not, so that one's okay. Our next denominator is just x, so that's just a 4/3. That's not equal to 0. That's okay. Our last denominator is 5 times 4/3. That is not equal to 0, so that's okay. So our answer checks. I think I have 2 more examples here to show you, if my pen holds out that long. Brown was not good. Let's go back to blue. Okay, again, not a single fraction on each side, so we can't use that cross-multiplying technique. So we're going to start by identifying what is our least common denominator. Before we do that, we are going to need to factor the denominator over here on the right. This factors into x minus 4 and x plus 4. Once we have it in its factored form, we can see pretty easily that our common denominator is just going to be those 2 factors, x plus 4 and x minus 4. So start out by writing your equation, -3 over x plus 4. I want that denominator to also have an x minus 4 in it, so I need to put that on the top and bottom. Your next fraction is 7 over x minus 4. Again, to get that common denominator, this time I'm missing the x plus 4. Then this last one already has the common denominator, so I don't need to do anything to it. I'm just going to copy it down. We have an equation, so we can multiply this whole thing by x plus 4 times x minus 4. I'm just going to shortcut it and cross all those out. Remember, we can only do that with equations, not with expressions. And here's, plus. Here's what we need to solve now. We eliminated the fractions, a much easier equation to deal with. We'll distribute over here, so we get, watch your signs, -3 plus 12. Okay, combine our like terms over here on the left. We have a minus 3x and a plus 7x. So that gives us 4x. We have a 12 and a 28. So that gives us plus 40. Okay, I'll add 5x to both sides and subtract 40 from both sides. We end up with 9x equals -26. Divide both sides by 9. X equals -26 over 9. Not done yet. Whenever we have fractions, we go back and check. -26 over 9, when I plug it in here, is that going to give me a 0? And the answer is no. When I plug it in here, does that give me a 0? No. When I plug it in here, does it give me a 0? No. Again, you can do a quick mental check, or if you need to, plug those into your calculator. So that is our final answer. Okay, one last example just to make sure you guys have this. Here we go. Again, this looks really similar to the last one, so we want to start off by finding, I'll turn my pen on, what is that least common denominator? And maybe before we can answer that, we want to factor this piece. That denominator factors. So our least common denominator is just going to be those 2 factors multiplied together, x minus 2 and x plus 2. So there's the first fraction in our equation. If we want it to have our common denominator, we need to throw an x plus 2 in there. So we throw it in top and bottom. Our second fraction already has the x plus 2. So we need to throw in the x minus 2. And our third fraction already has that common denominator, so we don't need to change that one at all. Because these are equations, I can multiply everything by x plus 2, x minus 2, and all those denominators just cancel out. We are left with x plus 2 times 1, so the 1 goes away, plus x That's supposed to be a minus. X minus 2 equals 4. Again, so much easier to solve now that we've cleared those fractions. Over here we have a 2x. The plus 2 and the minus 2 go away. So we just have 2x equals 4. X equals 2 is our answer. Don't forget, we need to go back and check. When I take x equals 2 and I plug it in right here in my original equation, what happens? Well, I get 2 minus 2, which is equal to 0. That is a problem. That means that this is not an answer. And after all that work, what we have to say is that there is no solution to this equation. There is no value for x that will make that a true statement. So there's an example where our check saved us. If you put x equals 2 for an answer, that's going to be counted wrong. The answer here is we have no solution.